Hi everyone, I hope you're all doing really well. Welcome to our 21st live stream, I think it is. We've done an awful lot of these things, so I hope you're all doing well. Bit of a grisly old day today. Now, we have lots and lots and lots and lots to do, so please say hello in the comments and I will welcome you warmly. I need to finish off what I didn't finish last week and then get on with today's work, which is looking at robust program design. Okay, so that's the grand plan so far. So please say hello in the comments so I can warmly welcome you. I'm having I'm having issues with my mouse. Ah, there we go. It doesn't want to behave. Hi, Aditya. How are you doing? Good to see you. All right, so let's crack on. I'm going to whiz through this first bit, and hopefully we'll catch up with ourselves because we got a little bit behind last week. It's probably too much to get through. A couple of quiz questions just to get ourselves warmed up. What about this one? Which line in the program below calls the procedure? Hi, Bogdan. How's things? I hope all is well. Time is ticking away. 21 of these we've done, which is pretty extraordinary, isn't it? So what do we think? Which line in the program below calls the procedure? Oh, Aditya's come straight in with line 5. You know what? You are absolutely spot on. So let's waste no further time on that and move on. It is line 5. What about this one? Just a couple of questions to wet the whistle before we get going. Look at the program below. What would the value of new num be if the user entered the value 10? I imagine you'll pick this one up fairly quickly. What do we think? What would it be? So new num, work through the code. What would new num be? And of course, all this code, it's just a question of getting used to it and making sure that you understand how it works. Oh, Aditya's coming with 12 straight away. Look at that. That is absolutely fabulous. It is 12, so I am going to push straight on. Right, what's it all about? So this is the catch-up from last week. So I'm going to finish off the SQL, which is really straightforward. I now understand that I say it's really straightforward with everything that we do. It's straightforward when someone explains it to you, but it's actually, if you think about it, there's a system here at play with SQL, and I'll run through that. And then the last couple of things we looked at, arrays and subprograms and random number generation, and then we'll get on to defensive design. All right, that's the grand plan for today. But the SQL, it's really quite straightforward. So let's start off by looking at how this works. Sergen, welcome, dear chap. It was 12. You were spot on. And Hash Brown, how are you doing? Great to see you. Thanks for coming along. Right, we know that data is stored in a database, and a relational database is, you can think of it as a series of spreadsheets that are linked by something called the primary key, which is an identifier that works across all of the spreadsheets, basically. Okay, so an SQL is a series of spreadsheets that are relative to each other, hence the word relational database. All right. Now, if you think about Tesco, they've got a prices spreadsheet. They've got a spreadsheet about stock. They've got a spreadsheet for description and so on. So you've got all of these different ways of describing things, and these can all be held in a relational database on different spreadsheets. So we know that data is stored as a record, and if you imagine a spreadsheet, one line of a spreadsheet, a row indeed, would be a record. So it would have your name, your date of birth, your age, your phone number, your address, blah, 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 blah. Okay, so that would be one record stored across a line. And if you imagine the columns going up and down, I hope me moving my hands randomly helps a great deal here. The columns, they hold the attributes, the different elements that make up a record, okay? So in this example, name, age, and address, because this is a database that's going to hold people's names, their ages, and their address, okay? Now we know that SQL is structured query language because we learned that when we looked at SQL injections, and it's the language that's used to write queries for databases. A query is a question. So when you question a database to say, what are the 10 best-selling products? Who are the 5 least successful salesmen so we can sack them tomorrow morning? All sorts of ways of using a database. Pick out the students who've got the highest behaviour points, and then I end up talking to them and having difficult conversations. Pick out the ones who are hitting their challenge target grade. Pick out the ones who aren't hitting their challenge target grade. So databases are used for all of these. So think about it as a record, but you've got all of these different attributes within the database, okay? So the way that you can write an SQL query is you have three commands: select, from, and where. And the kind of overview here is that when you say select, you're choosing the attributes. So in this case, you're going to choose the attributes age and address from an imaginary table, okay? And of course, Mary is one of the is one of the people in this database. So in this example, we're saying select the following attributes: age and address, or you can use the star, the asterisk, which selects all the records. And they love that question at GCSE. How do you select all the records? The wildcard search, okay, the asterisk. So in this case, select the age and address attributes from student, and that from is from which table? So where are you getting it from, okay, from which table? And so therefore student would be the name of the table. There was quite a sneaky question that we looked at where they didn't actually say what the table name was. They just said what the table was holding. So that was going to be the table name. And then the last part is the where. That's the condition. So far you've said, look at these attributes in this table where the condition is, the thing you're looking for is Mary. So that would return Mary's age and address. All right. So we've looked at some examples of those sorts of questions, and it always boils down to select, from, and where. And very often the mark scheme is so prescriptive that if you get those three words in there and do nothing else, you might get something from it. But if you actually stop and think, what are they asking? They're saying which attributes, which table am I getting it from, and what's the condition? Okay, so those are the three elements you're looking for there. So that is SQL, and I appreciate that I'm rushing through it. 36, I think we're on track here. So then we're going to look at procedures. And we're going to look at two, actually. We're going to start by looking at procedures and we're going to look at functions. And they are similar but different. Procedures and functions are chunks of code that you can reuse. And rather than having to copy and paste in the code each time you want to use it, or simply having to rewrite it each time, you can save it as a procedure or a function. And then you can call it, which is the word they use for executing it, for making the code run. You can call it whenever you want to, all right? But to do that, you've got to give it a name. And you've got to save it as either a procedure or a function. Now, the two are similar in that they can both accept parameters, and parameters is a fancy word for saying a value, but of course we know values are stored in variables. So fundamentally, this is exactly what I did with you today in class, but this is what we didn't finish last week. So I'm just recapping it really, but not everyone was there with me. So this is exactly what we're doing. So the fact of sounding familiar means that you were listening, which is outstanding. And that's how you call it. Now, the thing you need to remember, another question they love, it's what's the difference between, well, let me tell you that a procedure doesn't return values. It's simply a set of steps that it will carry out, but it doesn't send a value back to the main program. Okay. So the way that you would write one, that you would create one, is you'd write procedure, that's the word, and then you would give your procedure a name. So procedure, whichever procedure you're writing, double numbers to double two variables, and then in the parameters bit you put in the variables that you're going to be using. And if you're using more than one variable, you just use commas to separate them. And then underneath that, where you can see the two forward slashes, that's where you write your code. So that is procedures done and dusted. Now, these are different in one way to functions, which that functions do generate a value. They generate a result, a number, a variable. Okay, they produce something rather than just doing a set of steps. Sequence of instructions, same thing. Chunk of code you can reuse. Exactly the same, except it produces a value. And guess what? The way that you write it is exactly the same. Function with end function, so you're using function rather than procedure. You then give it a name on the first line there, and then you put in between the brackets the variables that you're going to be using inside that function. Got it? So really, it's just a way of making you write pseudocode. The pseudocode they tend to make you write there, I mean, OCR called it the OCR reference language, but it's the same thing, right? It's just their flavor of it. So that's where you write your code, and it'll be fairly straightforward code, but they can put anything in there. So they can ask you to create a function or a procedure, but they also need you to understand and explain sometimes the difference between a function can can actually write something, can accept a parameter back into the program, whereas a procedure won't. So that's it. I hope that makes sense. But it's pretty straightforward. All right, so that's your functions and procedures. Right, last thing before we start the new part that I was meant to start today, only 10 minutes in, so I should get this done, is about file handling. So we know that text files are used to store data. That's not rocket science, that's pretty straightforward. We know that text files are used for this. But files have two modes. You can read or you can write to files, okay? So let's talk about the difference between those. When you read, you open an existing file to read, to input data, okay? To take out data, rather. And when you write, you can open an existing file or you can create a new file in order to write data. So one is looking and one is creating and writing data, okay? So that's the read-write. And if you ever get into setting up networks, and think about the shared area where I can put files in there and you can access them, but you can't save stuff to that area and you can't do anything with that file. You've got to make your own copy to make changes to it, okay? So that's the difference between read and write. Good. Now that that's out of the way, let's have a look at open close. So if you want to open a text file, you would use, guess what, open, and then the name of the file. Quite easy, isn't it? And guess what? To close it, you put in the variable name and then .close. It's really simple, isn't it? But it's simple when you know how. Go to the website, have a look at the exam reference language and have a look at the examples of how that works. You look through a few and go, okay, that's quite straightforward. But that's the fundamentals of it, okay? Reading, and it's the same principle. You to read the entire file, you put in the variable name .read, and to read it line by line, you would say variable name .readLine and put the line that you want to read between the brackets there. Simples. All right, writing too, and I mean, you can all read as well as me, but this is all that it is. But have a look at those examples and the ones that I've given you, just to make sure you feel confident, so that if you're asked to produce this yourself, you can do it. Again, write to a file, variable name .writeLine, and to create a new file, new file. So they just need you to show, I suppose, at level 4 and 5 that you understand what these are and that you can produce, you understand what they do. And then at level sort of 7, 8, 9, that you can actually write some code that includes these different commands. Okay, so that's file handling. I know I've whizzed through it really quickly, but just have a look at the examples, okay? And it'll all make sense to you. Boom, 12 minutes in. I am on track to get through this. So this is now going on to 2.3, which is producing robust programs. Now, what this is really all about is making sure that when you write programs that are easy to maintain. In other words, if you think about any app that's made, usually it needs to be updated at some point. So when someone goes back and looks at the code later on, is it easy to update for the programmer to update? And if not, how could you make it easier to update? And equally, how can you make the program run properly without any errors, without it being misused, without it crashing? So that's the purpose of what's called defensive design. That when you write a program, you write it so that you reduce the likelihood of errors, you reduce the likelihood of it being hacked or misused, and also you prevent the program from crashing. So the first thing we're going to look at, the first area, is about data validation. Now, valid means that something is okay. So, for example, you put your phone to your face and it will read your face and it'll say, yes, this is a valid user with the biometrics there, okay? So we know what valid means. A valid ticket means a ticket that is in date and works, right? So validation is a way of ensuring that the program won't produce an error because of an incorrect input. So to make sure that the data that's going into a program is the correct data. And think back to SQL injections we looked at. And we know that SQL injections are tagging on some SQL code onto a password to try to gain higher level access or unauthorized access to a database, okay? So we already know something about how this can be done. So when you write software, when you write an application, these are the types of validation that you need to think about. So first of all, you've got a range check, and that's to ensure that if you want numbers between 10 and 20, you can only accept those numbers and not accept 9 and not accept 21 or 2000, okay? So for example, if you were taking in someone's age, the age would have to be between 1 and, let's say, 110. Because if someone put their age as 250, either they had managed to become immortal and not told anyone, or else they were just being a twit. So that's what you'd use a range check for. And we've got length check, about the number of characters. So for example, when you put in a phone number, it's 11 characters long. So you know when you put in a phone number but not your own, because you don't want to be spammed by a website. If you don't put in 11 characters, it'll say it's not a valid phone number. Presence check. Presence check is to check a value is present. So for example, on a web input form, when they ask you to give all your details, if they ask for an email address and you don't put the @ symbol in there, it'll go, that's not a website, okay? And it might ask for a full stop. That could be part of it because it's going to be .co.uk or .com or dot whatever, you know, so that would be part of your email address. .org or, you know, whatever it is. Format check, to check if the value follows a specific format. Think about how you might format a date, for example. And we know that the Japanese have got the most sensible way of formatting a date because they go year, month, date. And that way it's automatically arranged in the right order. The Americans have got a very, very strange way. They do month and then they do date and then they do year. And we're sort of somewhere in between in the UK. So you can make sure that things are entered in a certain format only. And then you've got a type check to check if a value is of a specific type. We talked about data types such as it'll only accept integers, it'll only accept, you know, a particular data type, right? So that is your validation. Now, it's worth going through these using some mnemonics or a little mind map or a mind palace way of remembering these 1, 2, 3, 4, 5 different types of validation, because it's a very simple question to ask. And also, these are validation checks that you will be only too well aware of, having, you know, joined countless websites, that you get it bounced back to you and it says that's not a valid phone number, it's not a valid email address. So just think about what kind of validation check is behind those error messages that are being brought up. All right, we now go on to anticipating misuse. And there are not two ways, just 2 ways of anticipating misuse. I hate it when I see a typo after the event. You've got input sanitization, and that's to check that the data is correct before it gets entered. So for example, SQL injection, if you do input sanitization, you make sure that the data being entered is only the data that you want to come into the system. And then you've got authentication. And authentication is, for example, checking that the username and the password match. Notice that the username and the password matching doesn't actually stop unauthorized users if they've got hold of someone else's details. If you did authentication plus, you know, more authentication, so for example with a phone, then that might, you know, two-factor authentication, that might be more effective. And increasingly, that's what's happening. Each time that I try and get into my YouTube account from a new computer, it'll ask me. Each time that I go on my banking or that I try and buy something on PayPal, it does the same thing, okay? So that's a more effective way. All right, maintainability. I need you to understand that maintainability is about allowing the code to be updated by others. So the example I gave was that you've written a program and they release a new version of Windows, and you've actually got to update certain key points of your program, if that makes sense. So then you might have left the company because you've been so successfully being promoted and you've left and you're earning millions of pounds somewhere else. And some poor sap has now got to update your program, okay? So they open it up. So when you write your program, you want to write it thinking about those who might come after you to actually update the program. So first of all, the use of subprograms. If you write subprograms, it makes it easier to understand. You know, we talked about abstraction and decomposition. It's a form of decomposition, isn't it? That you're taking a big problem and you're making it into smaller problems. And that's what subprograms are. You're taking a part of the code and thinking, okay, I can put that there and that can be a subprogram. And the more that you can do that, the more maintainable your code is. Putting code in blocks helps hugely because it also allows code to be reused and recycled rather than having to write the thing over and over again. Then we've got naming conventions. Make sure the name's appropriate. Call things what they are. The example there is rather than using size, or rather than using S, you'd put size. Because then someone coming in and updating your code could look and say, oh, okay, size, that's going to be the size of whatever they've got there. And another example would be no space between names. You tend to do house num rather than house space num. It's just what you do when you write code. Underscores are also useful there. And then we've got indentation and comments. So indentation allows code to appear more organized and easier to read, but it also makes it easier to spot mistakes when you can see the different blocks of code. Now, lastly, we've got comments. Comments, and here's something they love to do a 1-mark question on. Comments do not have any impact on the program. You can write whatever you like in the comments, and it's not going to have any impact on the program. They're simply there for the programmer to be able to understand the different parts of the code and to understand how the thing works, right? So comments have no impact on the program as they run, but it does allow the code to be maintainable. 51. Okay, we've got 9 minutes. Testing, 2 types. You've got iterative and terminal testing. And don't worry, no one dies. Final testing or terminal testing. And really simply, iterative testing happens while the program's in development, and terminal testing or final testing happens after the program has been created. Both will happen, okay? Why is it important? To make sure the program does what it's supposed to do, whether it has any errors or whether it meets the user requirements and if there are any security issues. So testing is another way of ensuring that code is fully functional and that it does what it's supposed to do. Defensive design, okay? And then we go on to the 2 types of errors, syntax and logic errors. I think I've described syntax errors as being a kind of spelling mistake, and very often a spelling mistake, if they do it for you in the exam, they'll put, rather than print, they'll put prin, or there'll simply be something which doesn't tally up with the language code. The code doesn't follow the rules. So misspelling a statement, missing brackets, not declaring a variable. It's when you've got part of the language wrong, as opposed to a logic error, which means you are using the language, but you've actually made a mistake in that you've put a greater than rather than a less than. It's a dog trying to get in. You put a greater than rather than a less than. Do you remember the question we did on the funfair ride where you all created a funfair ride that rather than allowing people of a certain height to get in, you actually only allowed the smaller ones to get in, so therefore lots of people died. I'm glad it wasn't me going on the ride. So that's your difference between logic and syntax. Okay, so logic, the program will run, but it will give you erroneous result. The output from the program will be incorrect, and it could create infinite loops, and that's where the program's unable to resolve, and there's an iteration that just keeps going round and round and round and round and round, and your program will crash probably. Okay, so those are examples of the 2 types of errors. Test data. When you're testing a program, so say you've written a program which is designed to accept a certain input, let's say from 0 to 100, and you can talk about normal test data. Well, normal test data would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 99. Are we happy with that? Normal test data, data that should be accepted. The boundary test data would be 0 and 100 because it's on the boundary of what's acceptable. However, -1 or -1000 or 102 would be invalid or erroneous test data and should be rejected by the system and should generate an error, okay? Should generate an error message. So those are the 3 types of test data that you can use. I imagine I don't need to say any more on that. Normal, which is within the realms of what you're looking for. Boundary on the very edge but should work. And invalid, which is data that should be rejected, okay? Good. So that is test data. Where am I? 54. Right. Okay. We've made it through. I've gone very, very quickly there, but I'm trying to cover things as fast as I can. Quiz time. Okay. Question 1. Indentation, naming conventions, and commenting are all defensive design practices that help programmers read and understand the code they need to maintain. What other defensive design practice helps programmers to do this? Question mark. What do we think? I'm glad I'm not paid by the topic, because otherwise I have done 3 weeks worth of teaching in exactly 15 minutes. So what do we think? What do we think could be the answer here? For those of you whose heads aren't spinning with that, what do we think the answer could be? We're 25 minutes in. What do we think? I think this is quite a tricky question, actually. Any idea? White space. Interesting. White space. That's an interesting answer. I'm going to put you out of your misery and tell you that the answer is the use of subprograms. I thought that was quite tricky. Let's go on to the next one. What about this? Look at line 4 of the pseudocode below. The code is formatted using if because it's part of an if statement. What one word completes the sentence? We're looking at the formatting here. What is the word for what's happened on line 4? Any idea? Oh, Hash Brown is literally on fire, and so is Aditya. Hash Brown, you were the worthy winner of that one. And Emad's come in. Hi Emad, how you doing? Good to see you. It is indentation. With you've even got some extra vowels in there, Emad. That'd be good. Well done, Sergen. Outstanding. It is indentation. That is good. Okay, the answer is indentation. Right, next. What about this one? Authenticating users, regularly updating programs, and writing code that's easy to read are all ways of design. What word completes the sentence? It's a fill in the gap question, guys. What do we think? What do we think? Oh, Aditya has you just beat Bogdan, and guys, you are all nailing it. Hash Brown, Emad, Sergen, defensive. Right, that is all outstanding. 57, 3 minutes. I will finish on time, and I've caught up, which I'm pleased with. Have a look at this one. Which test has flagged up an error in the program that needs to be investigated? I did go through this this particular slide in about 20 seconds, so I'm hoping that some of this is stuck. But I think the notion of normal, invalid, and boundary actually makes a lot of sense. Whoa, I did just come in with 1. What do we think? Do we all agree with Aditya? Aditya says test 1. Well, so we've got Bogdan saying 1. Well, it's interesting. That is quite interesting, shall we say? Because the answer is actually 3. So have a look back at that and see why that may be the case. I'm not going to pause because I haven't got time. So what about this one? Bogdan 4. We had a few. We had a 1. We had a 1. We had a 1. We had a 4. We'd have got there eventually. What about this one? Look at the pseudocode. Can you see? Can you see why? If you go back and look at that after I put it back there for you, you will see why. Okay. That was quite a cunning question, that one. Look at the pseudocode below. Which type of error would occur in this program? Any ideas? 1 minute to go. How much more have I got to do? A bit, not much. I'm gonna have to push you. Let's set this for 20 seconds and see. MS. We've got a few. We've got Aditya who's come back with syntax, and we've got Emma who's come back with syntax. Should we see if we're right? The answer is it's a logic error. Again, go back and look at why that is the case and see where that is, okay? It's just practice, guys. Right, we are almost there. I think this is my last question, so I should finish on time. You've written a program, I'll set the timer, Read that for me. You've written a program that asks the user to input their age. Now you want to check the right message is displayed if the user enters an unrealistic number. What type of test should you use? What do we think? What type of test? You want to check that the right message is displayed if the user enters an unrealistic number. An age of 350. Either they're a Highlander or delusional. What do we think? It's 7 o'clock, which makes me panicky. I reckon we can give you 20 seconds on this, and then we can whiz through and finish. If it goes to 7:01, I will not forgive myself. Any ideas for this, guys? 10 seconds. Any ideas? Any ideas? Nope. Okay, time is up. So I shall push on. And that would have been an invalid data check. So make sure you have a look back at those to see which is which. All right, 7 o'clock. I finished on time. Oh, it's 7:01. Right, next time, Boolean logic. So that will be quite a lot to get through, but we'll look at Boolean tables and or not. And we will look at truth tables and combining and or not. Operators. And then we'll look at truth tables and have a look through all of those next week. So we'll do a very, very speedy tour of Boolean logic in half an hour next week. Guys, have an amazing week. I hope that was useful for you. I shall put it on YouTube in a few minutes' time, and I will let you have the PDF from this, okay? Have a great week, guys. Have fun. Take care. Bye-bye.